Today I'm going to do a tier list titled Killer Apps for Space. So this will be a ranked tier list of potential applications or services or products that could be the killer app. That is something that really helps to expand the orbital economy and help space exploration. So just like with the internet, people don't get rich with routers and hardware. It's the apps that make all the money. So what are the equivalent apps for space that will really lead to a big expansion in the orbital economy? So let's bring up the tier list. Here it is. I'll put myself in the corner here. So this is just a standard tier list. S tier is the top level, and then A, B, C, D, with A being better than B, and so on. So I have a number of possible applications. I'm just going to wing it. I've not really thought about this in advance, so I'm just going to give my thoughts. And if you disagree, then just leave your comments of why you think my ranking is wrong. So this is just for fun. I've not scripted anything, and it's just off the top of my head. So let's start with asteroid mining and how big that will be. So there's a number of startups working on asteroid mining. There's Carmen Plus and Astroforge, both of which I've covered on my channel. You can either go for the precious metals, or you can go to an asteroid that has volatiles, such as water ice, and you can use the water ice for filling up propellant stations, for instance. That's one possibility. I'm going to put that B for the moment. Maybe I'll change these rankings later on. So servicing and refining. This is also related to asteroid mining. You could mine a near-Earth asteroid and then send hydrogen and oxygen or water back to low Earth orbit to refill a servicing station. So this is an orbit fab propellant station. They've already got contracts with the US government to refill some US military satellites. I think orbital refilling and servicing stations will be big in the future, and it does tie in with asteroid mining. So I'm going to put that at the B level at the moment. Space manufacturing is also there. I'm going to put that C at the moment because it's less advanced than orbital refilling. We have one example with SpaceForge. In fact, this image is from a furnace in space in low Earth orbit that has a temperature of 1,000 degrees. That's hot enough to melt aluminium, of which there is a lot of aluminium in low Earth orbit, over 5,000 tons due to orbital debris. So it would be possible to reforge components and parts from orbital debris into new components, or you could forge metal pipes to be used for metal propulsion drives, which I've covered on this channel already. Manufacturing in space. You can also manufacture pharmaceuticals. So Varda Space is working on that. And a number of other companies are working or partnering with space companies to manufacture pharmaceuticals or drugs in space. So I'm putting space manufacturing at C because it's not as advanced yet as servicing and propellant stations. Orbiting data centers is potentially huge. I'm going to put that at A. So we know that Elon Musk and SpaceX are going to be working on very large constellations for AI compute. Elon Musk has mentioned 1 million satellites in low Earth orbit, and then going to the moon to use the moon's resources to manufacture billions or even trillions of these satellites. And I think we'll see a lot of other companies also doing that. Google is also involved, Blue Origin as well, StarCloud. And we had recently Anthropic working with SpaceX potentially on orbital compute. So I think this is going to be absolutely massive and drive a lot of investment into space. This will benefit the rocket companies, servicing companies in space for servicing the satellites, moving them to a graveyard orbit or deorbiting them or refilling the propellant tanks. Orbital data centers is a huge driver for the space economy. So commercial space stations, I'm going to put is either D or C. I don't know. I'm going to put it at C because I think in the future, maybe 10 years, commercial space stations could be viable, but in 2026, they are not viable, according to NASA. And if NASA is not funding these space stations, I don't know where the funding is coming from. So unfortunately, given NASA's priorities and the lack of private demand for these kind of missions, then I don't see them being viable for another decade or so. So that's why they're down in C. I think there's been 4 private astronaut missions, all by Axiom Space, and there's another 3 planned. In terms of free flying missions, there's been 3 so far, 2 of them funded by Jared Isaacman, And since he's a NASA administrator, he's not funding any more in the future. So there's just no demand, insufficient demand to support these very expensive commercial space stations. So I believe for the next 10 or 15 years, the only kind of space stations you'll see in low Earth orbit will be national space stations or space stations supported by consortium of countries like the European Space Agency. I don't think you'll see viable private commercial space stations. I could be wrong about that. For instance, Vast Space is flying Haven 1 next year. It's a very small, minimal viable product station. It may be able to support itself. It's quite small, and you could have occasional missions there every 6 months or every 12 months. So maybe I'm wrong, but I'm going to put it down at C. Orbital recycling, I'm a fan of this, and I've covered this in one of my videos. In fact, there's a startup called, I think, Orbit Recycling. And the idea is you take the 10 to 15,000 tons of orbital debris, and you can then recycle it using an in-space furnace, for instance, from SpaceForge, and you can then forge it into useful components or into metal tubes for propellant, or you can push the orbital debris onto a lunar impact trajectory, and then you can recycle the aluminium, for instance, on the moon for habitats or for road or rail or other kind of components. That would allow thousands of tons of metal to be sent to the moon much more efficiently than doing it from Earth. So I think that is a viable possibility, and that's why I'm going to put it B. In terms of logistics and supply hubs, I'm going to put that, at B level. So I did a video covering Firefly Aerospace's report to DARPA on a cislunar supply hub stationed at L1. L1, or Lagrange 1, is a balance point between Earth and Moon. It's about 2/3 of the way to the Moon, and there's very weak gravity at that point. So if you put something at L1, it kind of stays there, or it's very, very easy to keep it there. Minimal station keeping required. So it's a great point as a logistics hub, a supply hub, or a waypoint station. And then you can either go to the Moon, you can to Mars, you can go to low Earth orbit, you can go to Earth or to near Earth asteroid. So it's a very useful point in space. And you'd put supplies, you put propellant there, you could have habitats there. So I like the idea. So I'm going to put it B. I think it's kind of related to definitely servicing and refilling in low Earth orbit. So I'm going to put it B. So space-based solar power, these are the very large kilometer size satellites that can beam hundreds of megawatts and even gigawatts of power down to the Earth. So this would be 24/7 base load power that could replace power stations on Earth. It's a much more reliable form of power. You don't have to ship fossil fuels around the planet. The satellites are stationed over your region, over your location, and then you just beam power to 24/7. So when I mentioned about a European space station at 60 degrees, for Europe, you'd station these at 63 degrees at a highly eccentric orbit. For that, you definitely need probably heavy or super heavy launch vehicles to put all the components into space, and then you'd assemble them into these very large solar power satellites, which would be hundreds of meters and perhaps kilometers in size and weigh thousands of tons. So that's why I'm putting it down at C. I think in the future we'll be able to do that, but it's probably another 10 to 20 years away. So we need more progress on propellant stations and launchers, more heavy launchers and super heavy launchers. So I'm putting that at C for that reason. It's a little too early for space-based solar power. So helium-3 mining, I'm going to put, so I'm not sure. I'm going to put it up here because helium-3 mining is technically not difficult to do. Whether you can do it at scale is another matter. But this helium-3 is literally on the surface of the moon. It's everywhere. There's 1 million tons of helium-3, some of which is loosely bound and some is unbound completely. So it's at the very, very top of the soil. You just sieve it, and maybe some mechanical agitation, maybe some light heating, and you've got yourself a bag of volatiles. It would be helium-3, it would be helium-4, it would be hydrogen. Then you would separate out the heavy volatiles, maybe oxygen or nitrogen or some other inert gases, and the bag of light volatiles you send back to Earth, and you can see the rocket lifting off from the moon, heading back to Earth. And then on Earth, you separate out the helium-3 from helium-4, which is technically very difficult to do. You wouldn't do that on the moon. And then you can sell the helium-3 for $20 million per kilo. And don't forget, there's 1 million tons of helium-3 on the moon. So with a few hundred grams, you can go anywhere in the solar system with a fusion drive, such as pulsar fusion, and Zephyr fusion is also working on fusion drives. So all you need is helium-3 as a fuel and deuterium, and you've opened up the solar system for robotic travel. Fusion drives don't work well for humans because they're too slow, the thrust isn't high enough, but you can definitely open up the whole of the solar system for robotic missions and also supply missions to Mars to support a human outpost, for instance. So helium-3 mining is huge for space travel. It would also be very beneficial on Earth. It would power the fusion startups, lots of cheap energy on Earth. So helium-3 is definitely very exciting. This is in-space assembly and manufacturing, which is a key technology. For instance, for the supply hubs, it's necessary. For space-based solar power, it's necessary. And it would also help commercial space stations as you can build out these space stations. So I'm going to actually put this at C because there's not been much progress. There's not many space startups that I know of working on in-space assembly and manufacturing. I've done 3 videos on companies involved in this area. I've done Think Orbital, which is this an image of their spherical habitats. They basically send metal plates and then weld them together in space. Space Quarters in Japan has exactly the same idea of welding metal sheets together. And also Rendezvous Robotics, which has the idea of self-assembling tiles, which can actually connect themselves together. And they've demonstrated that on the International Space Station at a very small scale. And they are sending another experiment to the ISS. And these tiles are now dinner plate size, and they will assemble into a spherical object autonomously. So that's very exciting technology. So that's Rendezvous Robotics, Think Orbital, and Space Quarters. But this area is very new. This technology needs to grow to support building out commercial space stations and assembling large satellites such as solar power satellites. That's why I'm going to put it at C. There's not been much progress with this technology so far. Hopefully in the next 5 to 10 years, we'll start seeing structures assembled in space, being welded together in space. That would be great to see, but we're not there yet. Internet and AI constellations. So this is things like Starlink, or Amazon Leo, or OneWeb, and there's many Chinese mega constellations. Also Earth imaging constellations. You've got internet. You've also got AI compute, which will be extremely large constellations, perhaps millions of satellites. So this is obviously generating a lot of activity in space. You've got all the launch providers. You've got the companies working on satellite platforms, all the satellite components. Potentially, you've got orbital refilling and servicing, end-of-life management, deorbiting or graveyard orbits. So there's potentially a lot of activity for servicing and refilling. And I think this really benefits launch providers in a big way. So I just see that growing and growing. So that's very positive for investment into space, into the orbital economy, and in situ resource utilization, which I'll put up here. This is living off the land. So when you go to the moon, the idea is that when you go to the moon, you try to use the lunar resources as much as possible for breathable air, for water, for propellant, for metals, materials, ceramics, glass, silicon. So all of these materials can be made on the moon with the technology. So Blue Origin has been working very hard on this area. I expect SpaceX will with their Moonbase Alpha. And there's a lot of small lunar startups working on ISRU. I've talked about Ethos Space Resources, Argo Space, there's Astroport, there's Interloon. Initially, they're working on helium-3, but they will also then expand to other materials such as rare earths, metals, and oxygen, and other volatiles. I can see many companies working on ISRU, and of course it will be supported heavily by NASA. NASA wants to save a lot of money by not having to pay for resupply missions. So the more they can do on the moon, the fewer Earth resupply missions are needed. So I expect a big boost from NASA for ISRU on the moon. And of course that will carry over to Mars as well. That is my tier list. I mean, this is just off the top of my head. I'm sure you may have different thoughts, or maybe I've missed certain killer apps would be highly beneficial for the orbital economy in an expanding space. But these are the ones I can think of at the moment, and I put in 12 of them. So anyway, let me know in the comments below what you thought of that tier list and what applications, killer apps that I didn't include, that I should have included, or if you think my ranking is wrong. That's what I'm thinking at the moment. And some of the ranking is just based on, I think it's too soon. It's just another 5 or 10 years away. Thank you for watching this short video on killer apps for space. And I'll see you next time.